Hi everyone, in today's video we're going to be discussing rotations. A rotation is a transformation that turns a figure about a fixed point called the center of rotation. An object and its rotation are the same shape and size, but the figures may be turned in different directions. Let's discuss the direction of rotation. First, we have the positive degree of rotation, and that's counterclockwise. Then we have the negative degree of rotation, and that's clockwise. That's in the direction of a clock. The center of rotation is the point around which the rotation will occur. Every rotation has a center of rotation. Let's take a look at the unicircle in this diagram. The first thing that we notice is that each quadrant is labeled. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and those are represented by Roman numerals. So in my quadrant 1, I go from 0 degrees to 90, then 90 to 180, 180 to 270, and then 360, I'm back at 0 degrees. Remember, when we do this, we're going counterclockwise, the opposite of a clock. Each quadrant we rotate is 90 degrees. Let's take a look at the first type of rotation. We have rotation of 90 degrees counterclockwise. So the point of the pre-image is before the transformation. So in the diagram, triangle ABC is the pre-image, and I'm going to label that with a 1. After the transformation of a rotation of 90 degrees, the image is now negative y comma x, and that's represented in triangle A prime, B prime, C prime. The primes are these apostrophes. Rotation of 90 degrees is the same as a rotation of negative 270 degrees clockwise. So if I start in the first quadrant and I rotate it 90 degrees counterclockwise, I end up in the second quadrant. All I have to do is take x comma y and change it to be negative y comma x. So if I look at B, which is 1 comma 5, I need to find B prime. I take the y value, which is 5, make it negative, and then bring down the x value, which becomes the y value, negative 5 comma 1. Next, we have a rotation of 180 degrees, and that's represented the same way, both clockwise and counterclockwise. So for example, my pre-image, which is before the transformation, is represented in triangle ABC. I'm going to put a 1 because that's where I start. That's in quadrant 1. To rotate it 90 degrees, I would then go to quadrant 2, and then rotate another 90 degrees, would be in quadrant 3, which is a total of 180 degrees. And my image, which I'm going to put a 2, is triangle A prime, B prime, C prime, and all you have to do is negate the x value and the y value. So for example, if I look at B, B is 4 comma 1. If I wanted to rotate B 180 degrees, I would have to negate both the x value and the y value. So negative 4 comma negative 1. Next, we have a rotation of 270 degrees counterclockwise, which is the same as the rotation of negative 90 degrees clockwise. So let's identify the pre-image, which is before the transformation, A, B, C, D. I'm going to put a 1. And then after a rotation of 270 degrees, I have A prime, B prime, C prime, D prime. That's represented by 2. I started in quadrant 1, If I rotate it 90, I'm in quadrant 2. If I rotate it 180, I'm in quadrant 3. And if I rotate it 270, I'm in quadrant 4. All that I have to do is take x comma y, and it becomes y comma negative x. So let's look at point C, which is 3 comma 4. C prime, I have to take the y value, that becomes my new x value, and then I negate my x value, and that becomes the new y value. The minimum angle of rotation is the smallest angle through which the figure can be rotated to coincide with itself. This number will always be a factor of 360. The general formula for the angle of rotation is 360 degrees divided by n, which represents the number of sides in the figure. So we want to rotate a figure the smallest amount of degrees in which it looks exactly like it started off with. Let's take a look at this example. We have a hexagon which has 6 sides, and we want to identify the minimum angle of rotation. So we're going to do 360 divided by 6, which is 60 degrees. So for example, if I take my hexagon and I rotate it 60 degrees, it's going to look exactly the same as if it started out with. In order to find the other angles of rotation, I take 60 and add 60 to it. So that's going to give me 120. Add 60 again, 180, and so on. Until you get all the way back to 360. So my minimum angle of rotation is 60 degrees. And my other angles of rotation, I continually add 60 degrees. So 120, 180, 240, 300, and 360. In some questions, you may see the word onto. Onto means when you rotate a figure about the center, the figure looks exactly the same. Each vertex lands on another vertex. So let's take a look at these two example problems. Which rotation about its center will carry a regular decagon onto itself? So I see the word onto, so that makes me think of 360 divided by n. A decagon has 10 sides, so I have to do 360 divided by 10. That gives me 36. However, 36 is not one of the options, so what I have to do is take 36 and continually add it to itself until I get one of the answers. Another way to do this is divide 36 into each answer choice, and whichever one is even is the correct answer. So when I continue to add 36, I get 36, 72, 108, 144, 180, 216, 252. Notice I see 252. That has to be my answer choice because 252 divided by 36 gives me an even number of 7. In the next question, which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? So again, the minute I see that word onto, I know it's 360 divided by n. In this case, it gives us degrees, so we're taking 360 divided by 45, and that's going to give us 8. And this tells me how many sides. So an octagon has 8 sides, so it has to be answer choice 1. When looking for the minimum angle of rotation, always do 360 divided by n.